Hello! I hope you guys are doing well. A nice smiley face, Erica. I hope you guys are doing great. How's it going, Leah? Very good. Delara, awesome. I see Becky and Amanda and Chelsea and Jennifer and Erica and Tyler and Samantha. Awesome. How you doing, Barbara? Everyone's good. Becky, I am recording, and I'm trying to do this outside. We'll see how it goes. It's the blue sky, so I think we're going to make it. Yeah, how are you guys doing? I hope you guys are well. I got a little bit of a congratulations for you. You're now halfway through. Screw that, man. Nice hair, buddy. Jesus, Murphy. Anyway, you guys are halfway through. This is week 6, and we haven't even really started yet. You know, we've been getting into, what have we been doing there? We've done cells and tissues. We've done bones and muscles. What else we done there? We've done lymph. All right. And today we're starting to gravitate in a different direction. Everything we've kind of done, well, bones and muscle, those are pure organ systems, right? And oh, hi, I think someone's mic is on.
I do too.
It's all good. I don't know whose microphone is on, but it's anyway. We are moving in a direction where next week I think we're on to the cardiovascular. We're on to digestion, and we're on to renal, kidneys, these are the good ones. And you guys have got nervous system, and I hope you guys are looking at that. Some people have actually already handed it in, and I did that on purpose just because I could have got you guys to do writing an essay and this and that, but you know what? The purpose of this course is to just hit you guys with organs and organ systems and cells and tissue, and honestly, this is pure memorization. So that's why I did the assignment there the way it is. We're off on good and better stuff. Is there anything there that is an emergency? Is there anything there that's going on there that I'm not seeing? You guys have been pretty quiet, and that tends to mean you guys have been pretty busy, and I like it. Your test there last week, again, excellent. I think the class average again was 78, and you know what I mean, that's where you want it. And if there's any issues, let me know now, because this is week 6, but only 25% of the course is in. We had test 1, which was 10%, I think, and last week's test was 15%. So there's only 25% of the course in. If there's any issues going on that you see, you feel that is going to happen, or if you're just not feeling confident, email me. We set up a time. We WebEx. Okay? I think the majority of you guys are doing really great. And you just keep on trucking. I think that there is teacher evaluation. I don't know how it looks on your guys' end, but there's a teacher evaluation there, or a course evaluation. Please have a look at it. Please be honest. If there's something there that you didn't like, say it. It's all good. I'm confident in myself as a teacher. I know where I'm at in the universe, you know. So if there's any issues, you know what I mean, write it down. And even the opposite side, is there anything there that you liked, you know? And it's all about positive reinforcements, because I do read these. I read every one. They're completely anonymous. You know what I mean? It's not it's not about that. I know I'm doing all right, but I know I can do better. So if you see anything there that I can improve upon, shoot me an email, even, you know. and because I'm trying to do the best that I can with the tools that I have. But if there's no emergencies, everything is good, then I'll just shut up and get going. Next week, another test. But you guys know what's coming. It's all good. And you guys are doing everything you guys need to do. So just keep ripping it up. And you guys are blowing the lid off this course, and I like it. I do. All right. Just let me dig here for a second here and get to my PowerPoint. So hopefully there you guys all have everything there that you need. You guys have the questions and all that. So, but if there's any issues, you guys will let me know. But here we go. I am recording. We'll hit endocrine system, and then we'll do chapter 15 afterwards, okay? Now, I do need to say that you're going to see specific parts of the body that you probably haven't seen there before yet. And it's all right. Don't worry about it. You're going to get there. But I've said this there before, that there's two ways that the body or my brain talks to my big toe. If, you know what I mean? If my, the first way there is the nervous system. It's very fast, it's quick, it's efficient. Ow, man, that hurts. Woo. So you see, something irritated my toe, which then sent off a nerve impulse, which then all the way up to the brain, and then back down again. And if we get into something there called a reflex arc, you'll see there that the nervous system doesn't even go to my brain. It just goes to my spinal cord and then goes back. And, you know, your whole idea of reflex. All right? Your brain is not even involved in that. That's spinal cord. But we'll get there. We'll get there. It's called the reflex arc. But there's two ways that the body talks to each other. Number one, nervous system. Very fast, effective, short-lived. Okay? The other way that the body or the brain talks to my big toe is the endocrine system. Okay? It's not based on electrical impulse like the nervous system. It's based on chemical. And as the nervous system is a very fast, effective way to talk between two body parts, this is also a very effective way, but it's not fast. It's very slow. Slowly. But then it can get enormously powerful and last for a week or weeks. Okay? And if you look at the female menstrual cycle, the hormones that are involved in there, when we get to that, you'll see the hormones that are involved in this on a monthly basis. Okay? And how powerful they can be. So that's the whole thing there with the endocrine system. And because we're hitting this before we actually hit the actual organ systems, you're going to see some parts of the body there that are going to look a little familiar. Well, I'm sure everything looks familiar, but you're gonna see like the pituitary gland and these kinds of things here. That's all right. You guys will get there if you haven't got there already there with the nervous system and all that. But and I do have some movies there. By the way, I want to check something out. I'm going to put just this video link in here and tell me if y'all can. I'm going to stop sharing for a second here to get my screen. Can you guys hit this link and does it play a video? That's okay. I'll wait. Just give me a thumbs up or a thumbs down if you guys can play that video. It's on hormones. Is that a thumbs up? And we've got a thumbs down. I've got thumbs up. Wow, I've got these. How is that even possible? Well, okay, that makes me happy. Okay, I've got thumbs up. Then what I'll do is if we've got some people, because this will actually be really good if we can. I've got all these videos here. that I won't waste video time or class time here with them, because there's a whole bunch. But y'all can have a look at these and play them again. These are those videos that I'm talking about that it's taken me a while to get. And, but yeah. So what I'll do is I'll post this. So I won't bother to play any of these videos. We'll just go through the PowerPoint, and then you guys can watch these videos and watch them again. And these videos are really good. Oh, thank goodness we have them there for digestion and respiration and cardiovascular. Ugh, because it's impossible to teach those courses without some type of animation. And what I'll do is I'll post all these videos. Y'all can watch them there at your own leisure. And the nice thing is they're like 1 minute long. So they focus on one thing, and bang, that's it. And if you didn't get it the first time, you watch it again, and you'll waste another 1 minute of your life, and you'll get it. So it's I like the videos on YouTube, but they're like 10 and 12 minutes long, and they just kind of get long and convoluted, and you get lost in it. I like these videos because they're 1 minute, bang. So good. Anybody, I saw some thumbs down. If anybody can't play the videos, I don't know what I'll do, but you'll need to get a hold of me. And I don't know, we'll have to maybe break some copyright laws. All right. So anyway, we'll get on to that. Okay. So that makes me happy there. We've got some videos. I'll post those videos there later. That is good. All right. Let's go. Endocrine system. These are the things there we're going to talk about. We're going to list the functions of the endocrine system. We're going to discuss the roles and functions of hormones. Now, there's going to be a whole bunch of hormones going on here. And, like, you guys have a test on this next week. Okay? And a lot of what you're going to see there today, we haven't really covered that organ system. Whether it's kidneys, the renal system, or whether it's respiration or whatever. And so, like, for next week's test, I'm not going to go heavy on anatomy, physiology kind of a thing. I'm going to be more, like for this section here, more into hormone and its function. But don't worry, it's all good. We'll go through it all, and I'll tell you what you guys need to know there for next week. Define hormone. Explain the process by which hormones bind to the receptor. Okay? Explain 3 mechanisms that control the secretion of a hormone. Okay? Now we're into the pituitary. Yeah, it's about this big. That's it. Very, very importante. Describe the relationship of the hypothalamus to the pituitary gland. And hopefully there y'all have had a look at your nervous system. And you guys, these seem a little familiar. Okay? And if they don't worry. We'll get there. Describe the location, regulation, hormones of the pituitary. Okay. So, you have a look here. Endocrine glands. I'll see if I can zoom in a bit. We've covered a couple of these there. Okay. Let me zoom in big time here. So there's your hypothalamus. Okay. Your pineal gland. That's an interesting one. Pituitary. Weird little hanging little, it's like an orange and a smaller apple in a bag. That's what it kind of looks like hanging down. You have your thyroid. Okay? And then you got little dots on the thyroid. We call them parathyroid glands. These guys here are involved in calcium uptake and reuptake. We'll get there. Told you calcium was important. So you got your thyroid, your parathyroid. It's on the backside, 4 little dots. You got your thymus. Okay? On top of the kidneys, you have these 2 adrenal glands. Okay? Pancreas. Okay? You're going to see there that the endocrine, there's also called an exocrine gland and an endocrine gland. One has ducts, the other does not. But they both kind of do the same thing. We'll get in there. Okay? So all of these guys here, endocrine. Okay? They don't have a duct that shoots out the chemical or the hormone. into the bloodstream. That's what endocrine means. There's no duct. Okay? It just leaves, and then this chemical is in the interstitial fluid, and it eventually makes its way out. Sorry you can't see my hands. I'm actually being very artistic here. But the hormone just gets released by the cell and just kind of floats around in the interstitial fluid and eventually makes it to the bloodstream. That's an endocrine gland. An exocrine, there is a duct, there is a vestibule, there is a tube that is there to shoot out the chemical. So there's endocrine and exocrine. All right. We've got the testes there in the male. Okay. We've got the ovaries there in the female. Collectively, we call those there the gonads. We'll hit those there when we do reproduction and anatomy and physiology there of the sex organs for sure. Need to blow out here. So hormones play an important role in growth and reproduction, okay, along with the regulation of water, electrolytes. There's mineral uptake, vitamin uptake. Hormones there, chemical messengers that influence the control of activities all over the place. Classification, protein hormones, steroid hormones, okay? With if you read down here, with the exception of secretions of the adrenal cortex and the sex glands, all hormones are protein or protein related. An interesting little tidbit there. The adrenal cortex on the kidneys and the sex glands, they secrete steroid hormones. It's a good one. Adrenal cortex and the sex glands, they produce the steroid hormones. Pretty much all others there, okay, protein or protein related. Okay. Hormones can have one or more target tissue. So when a hormone is released, okay, and it eventually makes its way to the blood, okay, it just gets sloshed around by the blood, right? It's just, what's wrong with my photo here? Sorry, guys. There we go. So when the hormone is released by the blood, or released by the, let's say, the pituitary, it has an intended destination. Whether it's the big toe or the kidneys or wherever it is. But a hormone can have multiple destinations depending upon binding sites. We'll get there, okay? And so hormones can have a turn-on effect, but they can also have a turn-off effect. Let's go. Target tissues, there are many target tissues result in more widespread effect. With fewer target tissues, they become fewer effects. So each hormone binds to a specific tissue called its target tissue or organ, and this may be located close or at a distance. Okay? So hormone receptors, and that's exactly what they are. Okay? And you'll see here that there is a whole process of how a hormone comes into the cell. Now, if we go to these ones here, all of these here, hormonal communication. Let's try one of these. Let's see if it works.
Hormonal communication generally begins with a part of the neuroendocrine system receiving sensory information and reacting by issuing a command to the body in the form of a hormone. In this...
Okay, I just need to know, I'm going to stop sharing and look at your... can you guys hear that? Was it okay? Yeah? Okay, all right. Thank you. That's what I needed to know. That's all right. Okay, let's go.
This example, dehydration is detected by osmoreceptors in the hypothalamus, which then directs or stimulates the posterior pituitary gland to release antidiuretic hormone, ADH.
Now, you see right here, blood volume and pressure drops because you're dehydrated. And you think about that. If your blood pressure drops, there's not as much pressure in the blood. Why is there not as much pressure in the blood? Because there's not as much water. Because your veins, your arteries are this big, but if you only have this much blood in there, you don't have enough pressure. And if you drink some water, now you've got more blood volume because your blood is made of water, right? So you've got these receptors there, and what happens is there's a problem. We need some water. So then what the posterior, and you'll see here, this whole thing here is your pituitary gland. And you've got your posterior, which is behind you. You got your anterior. They do two different bananas, completely two different things. This one here, it sends out what we call antidiuretic hormone. Okay? Antidiarrhea hormone. Diarrhea, we all know what that is, right? It can be very deadly because you lose water very fast, right? And so antidiuretic hormone, what do you think that's going to do? Antidiarrhea, we're going to keep that water in. We're not letting any water go out. Let's go.
The next step is to transport the hormone molecules to target cells. This is typically done via the bloodstream. Here, ADH is transported through the bloodstream to the kidneys and blood vessels. When hormone molecules reach target cells, they will bind to matching receptors on those cells, and the hormone receptor complexes will trigger changes in the target cells. This causes the kidneys to reduce the urine volume output, thereby increasing water retention and countering dehydration. In blood vessels, vasoconstriction is increased, leading to higher blood pressure and thus countering the blood pressure drop caused by dehydration.
Perfect, eh? Oh, I'm so happy. That makes me very good. And you'll see here, these videos, here we've got the effects of epinephrine in the liver. Steroids, this is actually good for DNA translation and transcription. You'll see here aldosterone is another one. Steroids, thyroid hormone, adrenal glands, it's all here. And this is an excellent video. Type 1 and type 2 diabetes in a nutshell. Excellent video. Okay? So, let's go. So, the glands, there is a target cell, and you'll see that there's a whole system on how these guys try and get in. If there's a protein hormone, it can't go through the cell membrane by itself. It needs a little package. Okay? All right? So the Golgi, it makes the little vacuole there, makes a little package. It's now able to go through, okay? And goes right to the DNA and allows for the making of a certain protein, okay? If your hormone is a steroid hormone, and you remember the only two places that those are found. Go back to the previous slide. These guys here can just go right through the membrane. Okay? And that there's an exact receptor there waiting for it. And in this process, okay, activates the DNA and therefore DNA translation, transcription, translation, and we make protein. So that's the end result is you're going to make protein there from the DNA. Okay? How they get through the cell, though, is very different. Okay? Good. Feedback. Okay, so there's negative and positive feedback controls. And if we go back to homeostasis, remember that funky word there from week 1. It's, you know, like when you're playing volleyball or, you know, any type of sport, your coach always said you don't want to be relaxed and flat-footed. You want to be up on your on the balls of your feet there, the tops of your feet. You want to be ready to go. Okay, that's how your body is when it's dealing with regulation and regulation of all of your metabolism, everything that's going on. Okay, your body is never relaxed. Your body is always ready to go. You remember muscle tonus there from the test? Or, yeah, that's right too. Just that ability that right now I'm relaxed having a cup of coffee talking to you, but if I saw a bear right now, choom, I have that and you have that ability to instantaneously go and run a kilometer right now because you have energy and oxygen already stored in your muscles, right? So this whole idea of homeostasis is your body is never resting. It's always in flux. So how does it keep this? What's going on here? So feedback control, we've got a negative feedback and a positive feedback. Okay, biorhythms, sleeping. We go to sleep when the lights go out. We wake up when the sun comes up. Okay, there's even a monthly cycle. Some people even go by the moon. Okay, that's what we're looking for there. So let's have a look here. Control by a negative feedback loop. As levels of cortisol rises in the blood, okay, to a needed level, so we need more cortisol. So we increase the level of it. But then at some point in time, there's going to be too much cortisol. And what happens is that cortisol that was made because you needed it eventually turns off everything. And we'll show you this right here. I think I have a video here of feedback inhibition. There we go. I think, anyway. Is it coming? Holy. There we go. Have a look. There's some good words here.
Many of the enzyme catalyzed reactions that occur in a cell, such as those involved in the biosynthesis of an amino acid, are carried out in a specific sequence called a biochemical pathway. In such pathways, the product of one reaction becomes the substrate for the next reaction. If the end product of a pathway, such as an amino acid, becomes available in the environment, it is unnecessary and wasteful for the cells to continue to produce the product. Cells, therefore, have the ability to shut down a pathway when it is not needed.
And you see what's going on here is this pathway, make here, to make here, to make here, and then eventually here, this is what we're looking for. We're making this protein right here because we need it for some reason. And you'll see here, you're going to get an accumulation of these guys here.
In feedback inhibition, the end product of the pathway reacts with the first enzyme that is unique to the pathway. The reaction occurs at a site on the enzyme that is different from the active site, called the allosteric site. When the product binds to the allosteric site, the enzyme undergoes a conformational change and can no longer react with its substrate.
And you see, there's just too many of these now to be ignored, right? We needed more of it, so okay, we produced more of it, job done. Now we don't want to flood the whole body with this thing, so we just need enough there to get the job done. And when there's too much of it in the blood circulating, what happens is this now has the ability, there's too many of these now, it hits this allosteric site, which is another binding site on the same enzyme. Enzymes can have multiple binding sites. So if it was binding here, it's going here and making these guys, but what if there's too much of this there? Now it'll bind right here, And what happens is it turns it off.
There is no substrate for subsequent steps in the pathway, and the final product is no longer synthesized.
That's how that one goes. Okay? So, let's keep on trucking. So that's negative feedback, where the end product, an accumulation of the end product, ends up turning off the initial phase. Okay? Positive feedback. Okay? I use this example with labor. Okay? And it's the whole idea here is that, well, here I'll read it. A bodily change stimulates further change, so it's more of a propagation. It gets stronger and stronger, and that's what happens there. And there's, I don't know if there's a drug, if anyone here got a shot of this there during labor to induce labor, okay? But this drug here is called Oxytocin. It's made, it's naturally made, and what this does is this stimulates contraction, uterine contraction. During labor, pressure of the baby's head on the cervix stimulates the release of oxytocin. Okay, baby's inverted, and the head pressing on the cervix, okay, tells the brain there to release oxytocin, which then now stimulates uterine contraction. Okay, oxytocin stimulates their uterine contraction, further increasing pressure on the cervix. More oxytocin is released until delivery. And you see here, positive feedback, okay, is this propagation where it gets stronger. To induce labor in some mothers there, the oxytocin is given intravenously. And this initiates a positive feedback loop, okay, that ultimately leads to delivery. And this will not stop until the desired action is done. The baby is born. And then the production of oxytocin stops. So that's an example there of a positive feedback where it gets stronger and stronger and stronger until job done. And once the job is done, okay, it's not needed anymore. It's not like giving birth is in the same way as controlling protein function or something like this, right? The whole idea, get the baby out safely, happy, healthy, and get mama back to being safe and happy and healthy. Okay, so that's an example of a positive feedback. The pituitary gland and the hypothalamus. Okay, the hypothalamus controls the pituitary function, okay, and is connected to the anterior pituitary through capillaries, okay, and to the posterior pituitary through tissue. So the hypothalamus is controlling the pituitary on the front of the pituitary through capillaries, the back of the pituitary through tissue, okay? And there's your figures there, 14b, okay? So have a look at that one there, okay? These two are pretty big bananas when it comes to nervous function and control and hormones and this kind of stuff. So have a look at these ones for sure. The anterior pituitary as opposed to the posterior pituitary, okay? Why is the anterior pituitary called the adenohypophysis? And the posterior is called the neurohypophysis. Good little questions right here. The anterior pituitary is composed of glandular tissue. The posterior pituitary is a direct extension of the hypothalamus, which is nervous tissue. Now, you'll just remember there that the anterior pituitary is controlled by the hypothalamus by capillaries, okay? The posterior is basically tissue. It's kind of an extension of the hypothalamus, all right? which is nervous tissue. All right. Releasing hormones from the hypothalamus reaches the adenohypophysis through the portal capillaries. So the hypothalamus, again, controls the anterior pituitary through these capillaries. The posterior pituitary doesn't need these releasing hormones, okay? The posterior pituitary is actually connected to the hypothalamus. Hormones secreted by the hypothalamus flow through the capillaries, through the anterior. Okay, so two different things going on here. There are some movies here. Where is it? Yes, up in here. But you guys can have a look at those there. Let's keep going here. Yeah, have a look at these ones here. These are what we call the hormones of the anterior pituitary. And we'll zoom in, okay? Let's have a look here. The anterior pituitary secretes at least 6 hormones that are aimed at their respective target organs there, causing the organs there to secrete these hormones. And you'll see here, you see all these. You see that here we've got TSH, which is thyroid stimulating hormone. Its target is the thyroid. Okay? Adrenal cortical thyroid hormone right here. This is for the adrenal glands. We've got growth hormone. Okay, for tissue cells. We've got follicle stimulating hormone. Okay, for the testes and the ovaries. Luteinizing hormone. Okay, for the ovaries. And as well as testes. Oxytocin. I like this one. This one here is very important. Anyone here knows a midwife, which are actually becoming quite popular there these days, from what I understand. The whole idea of going into a hospital and all that, when people have been having children at home for thousands of years, right? So have a look at that. Oxytocin also has a dual effect of milk production. Okay, there's your antidiuretic hormone. Kidney water reabsorption, progesterone. We'll get into all these, okay? Please know, though, that here's your hypothalamus, and it is connected to the anterior pituitary through capillaries, okay? So the hormones would come up from here, and okay, they come out here, and they have their intended targets. Know their targets. We don't have to know them. You just have to be able to recall them for a test, right? And then you have your posterior pituitary, which is these two only. Okay? These two only. And you'll know there that the hypothalamus is actually connected via tissue to your posterior pituitary, so it's kind of an extension. This is nervous tissue. This is not. Okay? What else we got? Your anterior pituitary, your growth hormone, also called somatotropin, affects bones, cartilage, skeletal muscle, causes amino acids to build into proteins and fats to be used for energy, converts protein to glucose, okay, exerts profound effect on growth, okay? That's your growth hormone. And just to tell you a story there, that we had a cat, a stray cat. This would probably be a million years ago. Picked up a stray cat there from the, I was going to say the dog pound, but what's the cat pound? Whatever, SPCA. And it was a cute little kitten, but they had got it, I don't remember if it was a male or female, but they got it spayed or neutered too early. And so therefore now it didn't have any type of regulation as far as growth hormone. So this cat grew and grew and grew and grew to, I tell you, from head to bum, I don't know, 3 feet, 2.5 feet, and that's not even its tail. It was the neighbors were all freaked out because we thought we had a cougar. But I'm just saying there that that disease is called amygdala, and where you just grow and grow and grow and grow until you die, basically. So there's your growth hormone in a nutshell. And there's lots of information in here. I hope you guys have a read of these underneath here, because there's some really good information, which, you know what I mean, these come right from your publisher. I don't really know why this information isn't up in here. So you guys have access there to these PowerPoints. Please have a look at these. And growth hormone also affects electrolyte balance. Okay, stimulates the kidneys there to reabsorb sodium, potassium, and as far as real function of the kidneys and all that kind of stuff go, we haven't done it yet. So next week's test, I'm not going to go after any type of specific kidney function. Okay, I'm probably going to be more interested in hormones, where they came from, and their intended targets. Okay, and their function. But as far as any type of anatomy, physiology that we haven't really done yet, it wouldn't be fair. I wouldn't ask you. Prolactin. Okay, mammary glands. Okay, getting the milk going. As long as the lactating mother continues to breastfeed, okay, PRL levels remain high and milk is produced. Okay. Well, we got the tropic hormones. You got thyrotropin, or thyroid stimulating hormone, TSH. Thyroid stimulating hormone, TSH. Okay. Adrenocorticotropic hormone, ACTH. And you've also got gonadotropic hormones. Gonads, you can see where that one. Okay, that's the sex, the sex areas, and adrene. Where's that going? Kidneys. And you'll see there the targets. These are important. The targets. Therefore, TSH is the thyroid gland, stimulating it to secrete 2 thyroid hormones, which we have videos of right here. Okay. It's all right here, so you guys can have a look at it. Okay? Oh, I'm happy those movies are there. The target gland there for ACTH is the adrenal cortex on top of the kidneys, stimulating it to secrete hormones. And then you've got the gonadotropic hormones. Okay? You guys can have a look at those. We've got follicle-stimulating hormones, and we've also got luteinizing hormones, which we'll get into more of. I have great videos on those, but I'm going to hold off until we do the sex glands there later on in the year. Okay. Posterior, the backside. This side here is controlled by the hypothalamus, also called the neurohypophysis. Okay. We can zoom in a little bit. Same shot as there before. And you'll see here that there are neurons that actually connect. This is nervous tissue. Okay. The posterior pituitary gland is also controlled by the hypothalamus, but not through the secretion of releasing hormones. Okay. Posterior pituitary is basically an extension. And there's your 2 there. There's your antidiuretic hormone, ADH, targets the kidneys, and oxytocin, therefore stimulating uterine contraction. Are we good? Perfect. There's your antidiuretic hormone. You guys can see that. Absence of the ADH results in diabetic insipidus. Causes blood vessels to constrict. Okay? That's important. Because when there's a drop in blood pressure, and this is the kidneys. We haven't even got there yet. And that's why the last 6 weeks of this course are actually going to be incredible because of where we're going. And you're going to see there, the kidneys are the big boss, not the heart. And the kidneys, they need a certain amount of pressure always. I have no idea why I'm talking like that. But the whole idea that there's a whole bunch of pressure in the kidneys need that pressure to filter out all of the bad stuff that we need filtered out. And you got to have an elevated BP in order to do that. Well, if you don't have that elevated BP, the proper blood pressure that the kidneys need, well, the kidneys get angry and they start commandeering the whole body until it gets the pressure it needs. And if you don't have enough water, well, then you don't have enough blood in your veins and arteries. So what they'll do is they'll cause the arteries to vasoconstrict. So the arteries will get the amount of volume that's in there gets smaller. So therefore now, with the limited blood supply that we have, because I'm thirsty and I don't have enough water in me, the veins, arteries will constrict, vasoconstriction there. Okay, and you guys can read about all this there. We've talked enough about ADH. You guys can read all about it here. Okay, lots of good stuff there. Oxytocin, there you go, targets the organs for the uterus and the mammary glands. Okay, we've talked about that too. You guys can have a read of that. Okay. Other major endocrine glands and their hormones. We're going to identify the other endocrine glands or hormones, explain the effects of hyposecretion and hypersecretion. What hypothermia means low temperature. Hyperthermia means high temperature. So we've got low secretion and too much secretion. Okay? And I'm not going to get there yet. I'm going to do this one. The thyroid gland, okay, right here, okay, it's this butterfly-shaped beast, and it's interesting what it does. And why sorry, I shouldn't, there we go. This is where we want it to be. Okay, so follicular cells, they secrete T3 and T4, okay, into colloid for storage here. We've got the, here, why don't we just show you this right now, instead of me yabbering about it. Or is it right here? Thyroid hormone and thyroid gland. Let's have a look. Now, some of this here might be a little beyond where we're going, but it's not going to hurt you in any way.
The thyroid gland is the largest endocrine gland, located in the neck inferior to the larynx and anterior to the trachea. This butterfly-shaped gland has left and right lobes connected by a narrow band of thyroid tissue called the isthmus. The thyroid gland is highly vascular, giving it a reddish color. Blood reaches the thyroid via superior and inferior thyroid arteries. Superior, middle, and inferior thyroid veins carry thyroid hormones from the gland.
Okay, so you see, we haven't got to the cardiovascular system yet, but the CVS, yeah, it carries blood and oxygen and all this, nutrients, this and that, but it also carries hormones. Okay? The hormones there, they get released into the interstitial fluid, and eventually they make it to the bloodstream, which then gets carried through the whole body. And you got to think, it's all happen chance. If these hormones are targeting my big toe, well, they're just going into the bloodstream, and then I don't know where they're going to go. But they go through, and just by happen chance, that these hormones will hit their intended target and cause an effect. It's incredible. And you see here that the thyroid is completely circumvented with blood.
Beneath the fibrous capsule, the thyroid gland is composed of spherical structures called thyroid follicles. The follicle wall is a simple cuboidal epithelium of follicular cells that surround a central lumen.
See that? Cuboidal. Where was that? Cuboidal epithelium. That's right up your wheelhouse now. You guys are all over that.
The follicle lumen is filled with a viscous colloid that contains a glycoprotein called thyroglobulin. capillaries, and parafollicular cells are located in the loose connective tissue between thyroid follicles. Parafollicular cells, also called C cells, secrete the hormone calcitonin, which is involved in regulating calcium levels in body fluids. Calcitonin is the antagonist to parathyroid hormone. Thyroid hormone, or TH, is a general term that encompasses two specific hormones: triiodothyronine, known as T3, and tetraiodothyronine, known as T4, or thyroxine. Thyroid-stimulating hormone, or TSH, from the anterior pituitary maintains TH synthesis and secretion. In the first phase of TH production, follicular cells secrete thyroglobulin, which contains numerous tyrosine amino acids, into the follicle lumen. Iodide molecules, I negative, from the blood, cross the follicular cell and enter the lumen where they're converted to iodine, I. The tyrosine molecules within the thyroglobulin combine with iodine to form iodinated thyroglobulin, which can be stored in the follicle lumen for 2 to 3 months. In the second phase, follicular cells absorb iodinated thyroglobulin by endocytosis, and lysosomal enzymes hydrolyze the thyroglobulin to produce T3 and T4, which are secreted into the bloodstream. The primary effect of TH is to maintain normal cellular metabolic activity. In children, TH is especially important for the growth and development of many tissues through stimulation of the pituitary gland to release growth hormone. Excess production of TH, hyperthyroidism, causes increased metabolic rate, which can lead to weight loss, hyperactivity, heat intolerance, and goiter, or enlargement of the thyroid. Insufficient TH production, hypothyroidism, results in low metabolic rate and resultant weight gain, sluggishness, and sensitivity to cold temperatures.
Good. You can
The
see
thyroid gland is the
you can see there that there's some stuff there that, you know what I mean, I'm not going to go for. But there was some pretty good stuff in there. And there's another video, the thyroid hormone. And that goes into more detail about T3 and T4. And just the whole idea was talking about iodine. Where is, anybody know the only place that we can get iodine from?
salt.
You got it. Iodized salt. Merci, John. And it's the only, like, you eat chicken, you eat, eat your food. There's going to be iodine in there in small amounts, but it can be hit and miss. And the only true source of iodine that we have is we make it ourselves. And iodized salt. And iodine is very important there to metabolic activity. You'll see there, hypo, not enough. Hypothyroidism, you're very sluggish, you put on weight, you don't have any energy. But then too much, you have hyperthyroidism. And I think that's where you get the goiter. I don't know if you guys have G-O-I-T-E-R, goiter. You can do a quick Google search and you'll see there that they'll get a big, huge lump in their throat there. Okay, and that's from the thyroid. So have a look at that video there. Have a look at them all. They're all good. They're all knowledge is power. So when this goes on, what thyroid hormones do, you guys can see the video. Have a look at this. Please, I like calcitonin, all right? And it has an antithesis, the parathyroid. So there's the thyroid, and then there's the parathyroid. Okay? They work in opposite. One regulates calcium uptake, the other one distributes calcium. You know, it's back and forth. One controls it, one releases it. Okay? Abnormal thyroid secretion, we've got hypo and hyper. We've gone into the video there for that one. Y'all can have a look at that one. And you see, these PowerPoints are right from the book. So you have a look here. control of T3 and T4 secretion. Have a look at the video. Maybe we'll watch the video. Why not? Let's have a look here. Thyroid hormone. Just a PowerPoint is going on about thyroid, so we might as well just throw the video. There you go. And this kind of plays back into what you saw there before about hormones entering the cell. You'll see.
Thyroxin is a water-insoluble hormone that is brought to the target cell via a protein carrier. Because it is lipophilic, thyroxin can easily pass through the cell membrane. Thyroxin contains 4 iodines and is often abbreviated T4, tetraiodothyronine. The thyroid gland also secretes smaller amounts of a similar molecule that has only 3 iodines, called triiodothyronine, T3. Both hormones enter target cells, but all the T4 that enters is converted into T3. Thus, only the T3 form of the hormone enters the nucleus and binds to nuclear receptor proteins. The hormone receptor protein complex, in turn, binds to the appropriate hormone response elements on DNA. The binding of the hormone receptor complex has a direct effect on the level of transcription at the site where it binds.
And you guys will remember this there.
Can easily pass through the cell membrane.
Sorry, I'm just going.
Of a similar called triiodothyronine.
Where did that go now? Sorry.
Nuclear receptor
this
proteins.
Is where I wanted to stop.
The hormone receptor protein complex, in turn, binds to the appropriate.
So this is now where, you see, this came in, bound to the protein, and this protein complex went straight to the DNA. So now, okay, it's going to transcribe. It's going to read the DNA. Okay, it's going to make a flimsy copy, your mRNA. And the mRNA is going to come outside the cell, and it's going to go to a ribosome where it's going to make the appropriate protein. I think we covered that there in the first test.
Appropriate hormone response elements on DNA. The binding of the hormone receptor complex has a direct effect on the level of transcription at the site where it binds. The messenger RNA, mRNA, produced then codes for specific proteins.
That's the whole nature of the beast right there. Okay, hormone came in, hooks up, tells the DNA to make a copy of the mRNA. The mRNA then leaves out, goes to the ribosomes where that protein is made for a particular reason, and there we go. Okay. Let's have a look. Need for iodine. It's all in here. You guys can have a look at this. And there's even a negative feedback loop that's involved here. Okay. And you see there that we release the hormone there. Okay. TRH, which then goes to the thyroid stimulating hormone, T3 and T4. And then once these guys are made, too much T3 and T4 end up shutting the whole thing down. That's how a negative feedback loop works, where too much of the end product ends up turning off the faucet there at the beginning. Okay? Need for iodine, we've talked about that. There's your iodine deficiency there, causes goiter. Calcitonin there is released by the thyroid gland. Okay, helps regulate blood levels of calcium and phosphate. Stimulates osteoblastic activity in the bone. Osteoblasts. What do? They build bone, right? Become an osteoclasts. B becomes before C. C, they degrade bone. So, if what we've got here, calcitonin, okay, stimulates bone growth. There's an increased excretion of calcium and phosphate in the urine. Okay. The parathyroid, and you'll see it's a parathyroid on here. Yes, it is. So here we're looking at the anterior side of the parathyroid, right? We're on the back side. Here's the person's spinal column. Okay, and the back of their head is right up in here. And you'll see there that on the back side of the thyroid, there are 4 little, honestly, they're kind of like just beans. That's all they are. These are the parathyroid glands. All right. And you'll see here that if there's low blood calcium, what goes on? What goes on? The parathyroid hormone goes in here and starts pulling. It tells the bones, the osteoclasts with a C, it tells them that they need to get calcium from the bones. So you're going to rob the bones of calcium, okay, because we need more calcium in the blood. So that's what's going on here, okay. Tells the kidneys there to stop excreting calcium. Tells the large intestine here to stop releasing calcium. We need to retain it, okay. So calcitonin, which is from what we've got here. The thyroid deals with calcium going to the bones. Too much calcium in the blood. We need to get rid of the calcium and phosphates. The parathyroid is the opposite. It's the antithesis. We need more calcium in the blood. So the thyroid and the parathyroid, the 2 glands, okay, they work in opposite, okay. The parathyroid, okay, raises blood calcium, as we just said, okay. Tells the bones there to give it up. Kidneys there, don't excrete it. Intestines there, they will absorb calcium, okay. So that's your parathyroid hormone. Blood calcium imbalances. The thyroid gland secretes calcitonin in response to elevated blood calcium levels. Calcitonin level lowers the blood calcium level. So again, this one works like this. So the thyroid and the parathyroid are working in a homeostatic environment. Okay. Oh, we need more calcium. All right, in the blood. All right. And then now there's too much calcium. So now we need to shift it back. And that's how the body is always regulating. And you could actually say it's over-regulated. But in such a perfect system as the body, there's no such thing. Over-regulation is exactly what the body needs. What do we got here? Parathyroid glands, abnormal secretion. We've got hyposecretion. Okay, hypocalcemic tetany causes carpal spasms. Hypersecretion, hypercalcemia, bone stones, moans, and groans. Have a look at that one. That one is painful. Okay. Adrenal glands. These are these little pyramid-shaped, triangle-shaped organs there on top of the kidneys. And I'm just trying to get over there. How do I get over there? There we go. There we go. So you'll see here that there's basically 2 major areas. We're not going to go into the kidney and what's involved there, okay? Not yet. We will. You've got 2 parts there to this gland. You've got what we call the adrenal cortex. What's going on here? Whoa. That was weird. It's like something just took control of my screen. Where did that go? That was really weird. Let's try this again, shall we? It's doing it again. Aha! I don't know what's going on here. See, it's just moving. Stop doing that. Okay. Then you know what? Okay. I don't know what's going on here, so you'll have to give me a second. Current slides. Come on. There we go. Let's go from here. So, the adrenal glands here, you'll see that you have the adrenal cortex. and you also have what's called the adrenal medulla in the middle. Okay? And they do different things. All right? And the adrenal it's doing it again. I want to show you guys. Stop moving. There we go. Sorry, I don't know what's happening. The adrenal glands there, they secrete two entirely different hormones. Okay? And this is figure 4.8 in your book there. The most important structures to note here are the outer and inner, the outer cortex, the adrenal cortex, and the inner there medulla. In the medulla, okay, this is the extension there of the sympathetic nervous system. And if you guys have gone ahead and read a little bit about the nervous system there, you'll see that there is your sympathetic and your parasympathetic. Okay? Your sympathetic is your fight or flight. Your parasympathetic is your rest and digest. So, the sympathetic nervous system, without going into crazy detail, because you guys are going to go and you guys are going to read all about it, but it's just the whole idea that if there's a bear there, boom, I am now superhuman in order to protect my own life. That's why we have this, and all of us have this. Like the whole idea there that a 90-pound mother of 3 could lift up the back of her Honda Civic to save her child who was trapped under the car. How is that even possible? Because we're all superhuman because of this, the sympathetic nervous system. And the two things there that I want you guys to know is epinephrine, adrenaline. That's what these guys are. There's norepinephrine and epinephrine, just basically adrenaline. Okay, and if you don't know adrenaline, that's what gives us our superhuman strength. It does a whole bunch of things, man. Gets the heart rate going, our pupils dilate so we can see things more clear, our hearing becomes more accusive there. Whatever, the banana that I have digesting in my stomach stops digesting, because if a bear's going to eat me, there's no point in digesting that banana. So forget that. Everything that goes on in the stomach stops. Okay, so that's what the sympathetic nervous system goes into. Okay, the adrenal cortex there. Okay, these are more steroid hormones, glucocorticoids, mineral corticoids, sex hormones here. Okay, so the adrenal cortex, the outside there, these guys here are more for steroid hormones. Okay, while the medulla is your adrenaline derivatives, epinephrine, norepinephrine. The glucocorticoids there, they affect carbohydrates. They convert amino acids into glucose. Gluconeogenesis. Okay, and helps maintain blood glucose levels there between meals. Okay, affect protein and fat metabolism, burning both substrates as fuel to increase energy production. Okay, there's your glucocorticoids. Mineral corticoids and sex hormones there. Aldosterone, okay, plays an important role in the regulation of blood volume, blood pressure, and the concentration of electrolytes. I have lots of good videos on this there, but I'm not going to go into them. I have one here, which we can have a look at. Aldosterone. Whenever it decides to, aha, excellent.
Aldosterone is a lipid-soluble hormone that can easily diffuse through the plasma membrane.
All right. I guess the
Inside the cell, aldosterone binds with an aldosterone receptor molecule in the cytoplasm. The aldosterone receptor complex
all right.
moves into the nucleus and binds to DNA.
The binding of the aldosterone receptor complex to DNA stimulates the synthesis of messenger RNA.
Same process as before, right?
Specific proteins. The messenger RNA moves from the nucleus into the cytoplasm and binds to ribosomes, where it directs the synthesis of specific proteins. These proteins produce the response of the cell to aldosterone.
Okay, so same thing as there before. The aldosterone there, you'll see when we get later on into the kidneys and all that, it plays a pretty important role regulating blood volume, pressure, and especially concentration of electrolytes. Okay, primary target organ of aldosterone is the kidneys. Aldosterone stimulates the kidneys' reabsorption of salt and water and excretion of potassium, because those ions you have sodium, potassium, calcium, they're all highly regulated. And when we get into the kidney, I would have liked to have, hormones and kidneys, they kind of go well together. It's just this course is so condensed that you're going to have to keep them separated there. But we'll get to kidneys, I promise. And all of these words here, aldosterone and these kinds of things, they'll make more, I'll put them all into context and all this, because I don't want to throw too much at you. So we're just kind of have our blinders on, and we're looking at hormones and where they're going, where they're coming from. We're going to kind of in-depthly, for right now, stay away from what exactly they're doing. But we'll get there, okay? We're almost done there, this PowerPoint, and we'll take 10 minutes and we'll have a break there. Abnormal secretions of steroids. Again, you've got hyposecretion, hypersecretion. I'm not going into, I'm not really a big fan of giving you guys, asking you guys to know about diseases at this point in time. I'm going to focus on the body. After you guys have nailed the body, please go and take a pathophysiology course and learn about diseases, okay? So diseases really aren't my focus, okay? At this point. The pancreas. This is a good one, okay? The pancreas is an endocrine gland. It secretes hormones through the interstitial fluid, which eventually make it to the bloodstream. But the pancreas is also an exocrine gland. Exocrine gland, there's a tube. There's a highway for some of this, for some of the chemicals to get out. Okay? Now, I think I do have, where is my, there we go, pancreas. Holy. Actually, your internet's probably better than mine, so what I'm gonna, okay. But this is such a good video. It really is.
The organs of the endocrine system secrete hormones directly into the bloodstream to assist in the regulation of various body functions. The endocrine gland discussed here is the pancreas. The pancreas is an elongated organ situated between the duodenum of the small intestine and the spleen, inferior and posterior to the stomach. It is both an exocrine and endocrine gland. The pancreas consists primarily of exocrine acinar cells and their associated ducts. Organized in glandular clusters, pancreatic acini secrete enzyme-rich pancreatic juice via the pancreatic ducts into the duodenum to aid chemical digestion.
So, when we get into digestion, we'll hit this again, all right? But the food comes in there, your tummy, and gets rolled around and just gets the heck beat out of it there by the hydrochloric acid. And then you get this slurry of highly acidic that comes out the bottom of your stomach. And it's so acidic that you see your stomach has mucus glands that protect the cells from the acid. So there's the stomach produces mucus. We'll get there. So that's what protects the stomach from the acid. And sometimes they're smoking, excess alcohol. There's even a bacteria there, pylori. I'll get there. I'll get it. That is actually the one of the culprits there to an ulcer. And when there's no mucus there to protect part of the stomach, what'll happen is the acid will burn a hole right through the stomach lining, and now you've got leakage from the contents of the stomach into you. Big problem. So this stuff is highly acidic, and the stomach is there just to break down the food, chemical breakdown, okay, with the acid, and mixes it all around. There's a bit of physical breakdown. But then this highly acidic slurry jumps out of the stomach and goes into the small intestine. Well, the small intestine don't have any mucus. So if this highly acidic stuff gets into the intestine, whoa, man, you're going to just burn that, you're going to burn that house down. So what happens is the pancreas, you see these ducts here? And there's actually a hole right in that connects the pancreas right to the small intestine. And it shoots in basically baking soda, which is a higher pH, which then the pancreas puts in baking soda, and then you have your acid, so now you'll have a pH in and around 7, so therefore now it's not going to burn a hole through your small intestine.
Scattered among the acini are small clusters of endocrine cells known as pancreatic islets, or islets of Langerhans. Each pancreatic islet contains 4 types of cells: alpha, beta, delta, and F cells that release hormones into the bloodstream. When blood glucose levels decline, alpha cells secrete glucagon, a hormone that stimulates the liver to break down stored glycogen and release glucose into the bloodstream. When blood levels of glucose and amino acids rise, such as after a meal, beta cells secrete insulin. Insulin stimulates cells to absorb glucose and amino acids from the blood and to store excess nutrients. Delta cells synthesize somatostatin. This hormone inhibits the release of insulin and glucagon and slows the activities of digestive organs, thereby slowing the entry of nutrients into the bloodstream. F cells secrete pancreatic polypeptide to suppress and regulate somatostatin secretion by delta cells. Together, these pancreatic hormones provide for the orderly uptake and processing of nutrients.
So just to let you know that these are the endocrine glands. They don't have a duct. They don't have a hole. They don't have a vessel, a way to get out into the blood other than just kind of the trickle effect, right? And you'll see here that these ones here are your exocrine. They have a tube. They have a vessel in order to get out. So I'll have a look at those ones there. The last video I want to show you is this one, and I'm going to do it because it's important. This one's on type 1 and type 2 diabetes. If it ever plays.
Now that you understand.
Okay. You know what? The internet here isn't very good, so you guys, what I'm going to do is I'm going to post this there to, I'll do that right now there to Blackboard, this list of stuff there. You guys can have a look at it. I'll finish this PowerPoint off, and then we'll take a 10-minute break and we'll come back. But please have a watch of that Diabetes 1 and Diabetes 2. Really, really, really good. Okay? The pancreas there's your alpha cells, your beta cells. Know which one produces which. Okay? Those are the 2 big bananas there when I'm talking about the islets of Langerhans. These are the endocrine glands there. Have a look at which one, be able to tell me which one secretes which one. You'll have a look here. The blood glucose levels rise. Pancreas secretes insulin. And now what happens is when you eat, when you drink a can of Coca-Cola, there's no fat in it. It's just, 13 or 14 tablespoons of sugar in it. So you drink a can of Coca-Cola, and now all of a sudden your blood sugar spikes, and I mean through the roof. That's how bad this stuff is. So then your body starts to produce insulin. And what the insulin does is it tells all the cells of the body, hey, we got too much sugar in the blood. You guys are ordered there to take in all the sugar and store it. Okay? As fat. So that's why if you drink 30 Coca-Colas in a day, every day, 7 days a week, there's no fat in it. It's only sugar. But you'll start to put on weight because your body will store that sugar as fat. Okay? Blood glucose level falls. The pancreas there secretes glucagon. Now, what is glucagon? What is going on here, man? It's so weird. Glucagon is the opposite of insulin. Insulin tells the body to take all the sugar out and change it and store it. Okay? And what glucagon does is it tells the body to take all the stored sugar off the shelf and change it back into glucose and get it back in the blood. So that's what these guys do here. What do we got here? Glucagon, other glands, the gonads, the thymus, the pineal gland. You guys can have a read of these. There might be a question, one. There might be a couple there on the gonads there, but we'll hit that later later on, okay? Other hormones there, prostaglandins there, they're secreted by most tissues there. They play a role in regulation of smooth muscle contraction, inflammatory response. It's all good. Adipose tissue hormones, not too really worried about these, but that's where we're at right now. It is now 1:20. I'm going to see if I can fix the internet here. But let's take 10 minutes, and I'll see you guys back here at 1:30. Is that okay? All right, guys. We'll see you back here in 10. Thanks, guys. I'm just going to mute it here.